Hi guys, so today we are going to learn about Python programming. So let me share my screen. My name is Asim and I'm going to show you a very difficult concept called as asynchronous programming with a very simple example. So let me know if you see my screen, right? So what I have here, first I want to tell you the difference between synchronous and asynchronous programming. Synchronous means continuous or blocking. For example, if you have the code which I have here is currently synchronous, which is sequential. So one function, once its execution gets finished, then next function is called, and then another function. It's a linear flow. You cannot do something which we call as non-blocking calls, which means that one function before it finishes, the control flow goes to another function and then it returns back to the first function again, something like that. So once you look in the code, it will be more clear. So what I'm going to do here is I have a main method, and inside the main method I have to find the highest prime below certain number. It's a parameterized method. Once I go here, then what I'm doing is to find the prime number, I am trying to do the step down by one, like whatever is the number, a number below that, until the lowest number, and I'm passing it to a is prime function, which will this is a logic. The logic, what it is doing, that whatever number it is having, it is trying to get the floor value, and if the number's floor value is exactly divisible, like is equal to the number division itself, then it's completely divisible, which means it's not a prime number. In short, the prime number is a number which is not divisible by any other number. So just ignore about the logic, just enjoy this and learn from it. So let me run this function. So what we did here is we technically called, let me do this here. What we did is we called this function main, and main function called these three functions, and each function try to run the logic, and after it ran the logic, it got executed. So it's synchronous because first this first function got called, then you got the answer, then this second time when it got called, first line got executed, then this loop got executed, it called this function, and then whatever, whenever the result came back, that got printed. Synchronous, this is not, probably you are here to learn. Now let's try to make it asynchronous, which means that you can run all these three functions in parallel, which means asynchronously. So one functions, the output of one function will not block the another function. What is happening here? Till the time first is not getting finished, second is not getting invoked. So I am going to rewrite this code or transform this code by the way of using asynchronous programming in Python so that we can run it in parallel. So let's get started with that. So there are two important keywords. This has started after Python 3.4. So one is called as async. So as soon as you put async in front of a function, it becomes asynchronous, which means there is a logic involved, which means it's a coroutine, and the coroutine would get invoked. And then there are some points wherein it would yield, for example, where you want to wait, right? So that is what will switch the context, which means if I am running a program and then that program is taking time to download the file from internet, so I don't want my flow to be blocked. I would say, hey, I'm going, I'll come back here after some time and see if you are done. Instead of sitting ideal, let me do some other work. That's how the asynchronous keyword will make it asynchronous. So if you run it, does it work? Does it become asynchronous? No, not really. So you will see that this is once you invoke the main, it would say it's a coroutine, and you did not find a point where it has to wait, right? So what is the method which you expect, the process to switch and take over the another function? That point is defined by await. So let's do that. So what I'm going to do is I am going to say whenever you're calling this, you have to uh, wait by doing await here for these three functions so that they can run in parallel. Let's try now what happens. So it is still saying you cannot call main like this. So to call the main, first thing is there is a concept which is called as event loop. So what event loop does is it would loop over and would see when the resource is available or when the program is done. So the event loop will check and then divide the resources. That's what is the task of event loop. So I imported the asynchronous module in which I am getting the event loop, and from the event loop, if we would run the main, we won't see this error like the coroutine. So any asynchronous program must be run inside the event loop so that it can be taken care when it's running. So let's do. Now we don't get that problem. It went here for the first program, but after that it got some issue. And what was that issue? Is object int can be used in await expression. So this guy came here, then it came here, and after that it basically it had some issue here. So let's do one thing. Let's also make this function asynchronous, because when we are calling all these three, and then unless they are not asynchronous, we cannot get the benefit of the parallel processing. So I made this asynchronous. Let's try to run this. So now pretty much it is running. Now it took some time here, and then it also gave us the result. But apparently this is also running in a sequence. First it went here, and then it provided the answer. So it's not truly asynchronous. Just to simulate, what I am going to do is I am going to make the asynchron like asleep, and then I would say await here. So what will happen is, just assume it's a function which is trying to take some more time, and here I can switch the context real quick. So let's see how it is going. So coroutine main was never awaited. That is what this guy is complaining the problem. So we'll fix that. Right now our execution is happening fine. It is showing us the time, how much it is taking. It is taking 0.61 seconds actually, right? So now we can fix it. Let me also make it in milliseconds so that it would make more sense when we run this. Now we see 571 milliseconds. Now we have to stop using this way. This is not the correct way. The correct way to invoke these in a non-blocking way is by asynchronous io.wait. So what this method does is, when you call main will basically have this trigger point, which means the yield point or the switchover point, and then you are calling all the functions in a iterable way. You can call any asynchronous function. You can actually pass any asynchronous function over here with parameter. So it would try to internally manage and call them in parallel. So now let's see what happens. See, we achieved this. So what it is doing now, it is really basically this function is now in a real sense doing asynchronous. How and why? So now again I commented this main. Why? Because it was giving trouble. It's a asynchronous function and you cannot invoke it directly. If you try to invoke, basically a synchronous function returns the coroutine, and that's what the error we were getting. Let me reproduce that for you. So that's what the error you was getting, and it was doing nothing. So to invoke this main function, we got the event loop. Inside event loop, we call this asynchronous main function, which ultimately called, the asynchronous wait, IO asynchronous wait, which called multiple asynchronous, like the functions which are asynchronous and which are taking some time. So wherever they are taking time, we call or mark it as await. So so long as this process is taking time, next function will get the chance of execution. So that is how, let me run it again. That is how the first line of the first function gets executed. Then it comes here. It's not finished. Once it comes in the loop at the first time, it thinks, hey, this is waiting, so let me give the opportunity to another function. So before the first function finishes, it gets halted over here. Once it's get halted, then it would invoke next function, second function, it would invoke third function, and then it would give the resource from wherever, whatever state the function it was. It would start processing from there itself. So any function whichever takes, less time or at that point in time, would be printed first. First means the result will come first for that. So this is truly asynchronous, and you see the time we take is 409 milliseconds, since it's asynchronous. But if we do not use this, and then if we try to go with this, it would still function, but let's see how much time it would take and what pattern it would run. So it is taking 500 milliseconds, and then it is going in a sequence. That is why, if we see it here, that it is not purely asynchronous. So I hope this has helped. When you invoke a asynchronous function, basically always try to invoke it by the asynchronous IO, which will take care of the parallel invocation, like the true asynchronous way of calling this. Whenever you come is inside asynchronous function, you must have a wait point, and a wait point is something wherein you can switch the context. To give the real life example, is if you walk into a hotel and you want to book the room. So you are at reception and there are 10 customers. So you say, if receptionist is talking to one customer, all nine, instead of waiting there, what they can do is, meanwhile their turn is not coming, they can go grab a cup of coffee, go to restroom, and then use that, and then they can come back. So they are still in the queue, but they are not sitting idle and waiting, and then they can be addressed by the receptionist to get the room keys and things like that in parallel. So that is how you can think of event loop as the receptionist. She is addressing all the functions, like all the customers. She is also on the phone addressing customers. So as soon as the resource is getting available, she is providing or directing the people towards there. But people, instead of just sitting ideal waiting in a blocked way, people are also been, doing multiple things, and whenever the resources is available, they get it. So the customer experience is faster. They are not waiting for longer time. In small chunks, they'll get whatever they need, whatever the resources they ask for. So, in nutshell, this is what the basically asynchronous programming is. I am going to check in this code, and you can find it in my repository in Python playground. There is a folder called as concept. So let me real quick check in this. So I'm going to check it in here is ASYNC asynchronous. PROGAM, push and commit. So now if you will go here and you will go in concepts, inside the concepts you will find a synchronous function. Just now we pushed it, and then just download this file, use it play around with it, watch this video with this, and then you will get the concept. If you like my channel, please subscribe it and leave your comments. Thank you.